Alright, here's an example of how to analyze the graph of this polynomial function. It's given right here. The function is that quantity x plus 4 quantity squared, and then times x minus 1 quantity squared. We're going to do parts a through f. So a says find the x and the y intercepts. For an x-intercept, you let y equal 0. So f of x is the same thing as y. So when you set that function equal to 0 and solve for your x's, if you set this quantity equal to 0, you're going to get x is equal to negative 4. And if you set this quantity equal to 0 and solve, you're going to get a positive 1. Now those are two different ordered pairs. So if you just ask you to list them, you just list them separately, negative 4 and positive 1. If they ask you to put them in ordered pairs, then it's negative 4 comma 0, 1 comma 0. Those are the x-intercepts. For your y-intercept, you let x equal 0, so you'll have y equals, if I plug a 0 in there for x, I will have a 4, and it's squared. If I plug 0 in there for x, I'll have a negative 1, if I square that. So that whole thing equals 16. Alright, as an ordered pair, it's 0 comma 16. Alright, those are your intercepts for part A. For part B, it says determine whether the graph touches or crosses at each intercept. Intercept is the same thing as a 0. So we have to look at the multiplicity, and then we'll tell whether it touches or crosses. So my zeros, I'm going to list them out this way, negative 4 and 1. Each of those multiplicities, again, those are the exponents on those linear factors. So those are 2's. Since they're even, it touches at each one of those. Let's do part C over here. Part C says find the power function that f resembles for large values of x in absolute value. That means if I were to multiply all of this out, that lead term would be dominant. So if I multiplied this out, I'll have an x squared. If I multiplied this out, I have an x squared. X squared times x squared will be x to the 4. Lead coefficient's 1. So the end behavior means both ends are going up that way. Part D says the max number of turning points. That's the degree minus 1, which is 3. Alright, that's A through D. E says find the behavior of the function near each 0. So this is for part E. Let's do near the 0 of negative 4. What you do to find this behavior is plug negative 4 into that original function, except for where it zeroes out the function. So you don't want to plug it in here, you're going to plug it in this side. So it looks like x plus 4 quantity squared, and then you plug the negative 4 in there and square it. Alright, so this part over here is a negative 5. If you square it is 25. Then I'll still have the x plus 4 quantity squared. So what this tells you, this is a quadratic that's shifted to the left 4. That's why it's near the 0 of negative 4, because it went to the left 4. And stretched by a positive 25. So it's above the x-axis, just comes and touches, turns around and goes back up. Alright, let's do it near 1. We'll do the same thing, f of x. We want to plug it in that doesn't zero it out, so we're going to plug it in this side, a 1. So I'll have 1 plus 4, that quantity squared, times the x minus 1 squared. 1 plus 4 gives you 5. If I square it, it's the same thing. X minus 1 squared. Again, what that shows, the behavior of your function near 1, this is shifted to the right 1, so I am indeed sitting there at 1. It's a quadratic, a parabola, opening up, stretched by 25. So it's coming in pretty steep, touching, turn around, and go back up, like that. Right, that's E. F says, let's put all the information together to graph it. Right, so let's use everything that we found up here to put this together to graph it. And I'm also going to plot some other points too. You'll see with the points that I plot, I'm going to have to change the scale up here. I'm going to go by tens. So that's actually 40, and this will be 10 here. Alright, those are just ones. My scale here is 1. So that's 1, and that's a negative 1. Alright, so I have a 0 over here at negative 4, and I have a 0 at 1. My y-intercept is up here at 16. So my end behavior, my right side's going up, and my left side's going up, and I know here it touches, turns around, it's going to go back, scoop up here somewhere, not exactly sure where, come back down, just touch there again, and then come back up. So let's just plot some other points in here. Let's pick some x values and plug in there. If we plug, what is this, 1, 2, 3, let's plug negative 3 in. When x is negative 3, if you plug it into your function, it's going to come out to be 16. So negative 3 and 16, it's about there. Right, it's equal to that one. Then let's also see, let's go ahead and plug, what is this, negative 2, just to see where that goes. If I plug negative 2 in, I should get a 36 out. Right, so at negative 2, I'm up here at 36, is around there. Actually, if you plug the negative 1 in also, you also get 36. Yep, just like that. Okay, also, if I go out here and plug a positive 2 in, I already have it at 0. If I plug a positive 2 in, this comes out to be, whoops, what happened to negative 1? It's up there at 36. And same with my 2 will also be 36. So at 2, it's way up here at 36. Alright, so what's going to happen is on the right side, comes in very steep like this, touches there, turns around, comes back up. Don't exactly know where that max is, but we're just sketching it. Alright, turn around, it goes back up pretty steep this way. Alright, so that is part F, where you have to draw it. So I think they give you a multiple choice one for F, where you pick the graph that looks like that. You'd have to watch the end behavior, also those zeros, and the y-intercept also.